Hey everybody, J.D. Teter here from Mation, Business Development Manager for the Motion Control Products. Joining us remotely is Eric Schaffer, the President of Schaffer Engineering. Eric is here to talk about a brand new product, the Trio Motion Toolkit for use with LabVIEW software. Eric is a longtime customer of Mation and the developer of the Trio Motion Toolkit, which allows you to use a Trio Motion coordinator along with a LabVIEW user interface. Eric?
Thanks, J.D. This is Eric Schaffer from Schaffer Engineering. I'm a certified LabVIEW developer, and I've been doing motion for over 40 years. And 25 years of that, I've been using LabVIEW to develop my motion. So right now, I'd like to talk about my Trio Motion Toolkit for LabVIEW. This is the part one, the introduction. And again, I'm Eric Schaffer, joined by J.D. Teter from Mation. What I'm going to talk about today is about the history of motion with LabVIEW and give a future option doing LabVIEW with Trio. We'll talk about the Trio Motion hardware and several motion programming options, including running a program written with the Trio Basic, flagged by LabVIEW flags, programming with the Trio ActiveX functions, and executing the Trio Basic functions. We'll talk some more about the Trio Motion Toolkit, give a demonstration of some of the VIs, and then finally, where to find the toolkit. So let's talk a little about LabVIEW motion history. LabVIEW, NI has been providing motion for many years. Originally, it was with a product called Flex Motion. This was a PXI-based motion with low-level programming capability. It has been obsolete for more than 10 years. At a certain point, NI decided to develop their own motion, and they called it soft motion. It was program-supported motion. It was based on a compact Rio-based modules. It again is no longer available with NI. Its last release was in 2018, and again, no longer supported by NI. So let's talk about what we can do in the future, an option using the Trio controllers. The Trio controllers are developed by Trio Motion Technology. They've been developing controllers since the 1980s, and the hardware is supported by Mation. The LabVIEW motion is based using the ActiveX library from Trio. Now, J.D. will talk to you a little bit more about the controllers.
The MC family, or motion coordinator family, from Trio Motion Control consists of a variety of controllers, everything from traditional step and direction and analog to EtherCAT control, virtually any servo system. The Trio Motion Coordinators are a full-featured motion controller, meaning you can do any kind of motion. So indexing, camming, synchronization, gearing, whatever you can imagine in motion control, you can do using the Trio Motion Controller. It uses a basic like programming, which you'll see when Eric does his demonstration. It has the capability of controlling robotics, which again, Eric will talk a little bit about that. There's virtually no motion application that you cannot solve using the Trio Motion Controller.
I'd like to talk about multiple ways that you can use a program with the Trio controller. One of them, we can use the editor from Trio to create basic programs. That's the Trio Motion Perfect 5.0. And once we've created those programs, the LabVIEW program can interact with that program using ActiveX flags. Alternatively, we can use a set of Trio ActiveX functions from their library. This is limited to the functions, or any of the Trio basic functions can be executed in LabVIEW. So I'd like to talk to you about the software. I'm going to show you some of these functions, and I will open up the software reference manual for the Trio Motion Perfect so we can take a look at them. So as you can see, this manual has over 1,300 pages of functions, all of which can be accessed through the toolkit. This is a listing of the different commands, any of which are available. What I'd like to look at, which is a really powerful command, is about the frame. The frame command allows you to use pre-described functions available on the controller to do robotics. Once you've specified which kind of robotic frame you're looking at, then you can specify what it looks like, and then the programmer need only give the endpoints, and the calculations are all available on the controller. So let's now talk about the Trio Motion Toolkit. This is a LabVIEW add-on that supports the Trio Motion controllers, as we've said before, to run multi-axis motion for stepper and servo application. It includes a full instrument driver library and all supporting examples for every function. All of those options we talked previously about, it supports, and in the future will support EtherCAT drives and motors. The Trio Motion Toolkit was developed with NI, and it's been approved by the LabVIEW Tools Network and is available through them. It is installed using the VI Package Manager. Now we're going to go and show some of the different examples of motion that are available. So let's see what you get when you download the toolkit. You'll see on your LabVIEW 2020 or whatever LabVIEW, under your instrument library, you'll have a Trio Motion folder, all of which will become available. Part of it will have a basic program that will include basic programs that you can work with on the editor. It'll include examples, include all your functions, and it also include a README file. In the README file, this will describe exactly how to get all of the Trio functions, all their software and manuals, and then a step-by-step how to set up the Trio controller with LabVIEW. In addition, the README file includes tips on tuning a servo motor, which we can take a look at in a future video. So let's open LabVIEW and see what we have. So how do we get to the toolkit? Let's just take a look at New VI, and on your palette, under your instrument I/O, you can go to your instrument drivers and find your Trio Motion Toolkit. Now in the toolkit, you'll find your examples and all of your VIs. Now, like most instrument drivers, we've created a VI tree, and this is the best way to get a picture of what's included. From here, we can take a look and see all of the functions that are included and the examples. Alternatively, to find examples, you can go to your Find Examples under LabVIEW, search by typing in Trio, and all of the examples are also available through here. So the first one we're going to look at is how can we run a basic program from the Motion Perfect controller using LabVIEW. So here is our basic motion demo. So what I will do here now is open up the Motion Perfect editor from Trio. And what we have here is a program that I've provided with the files. This program, what it is designed to do is run the axis 5 times 25 millimeters or 50 millimeters forward when it gets the VR0 flag from LabVIEW, and then when the VR1 flag becomes true, it will return to 0 position. So what we're going to do here to demonstrate is we're going to open up, we're going to start highlighting. And let's start the program running. So as you can see here, it's waiting for the VR0 flag to become true. So our LabVIEW program, when I hit extend, it turns on that VR0 flag. So let's take a look at what happens. And then, as I say, we're waiting for the VR1 flag to become true. When I hit retract, we return at 50 millimeters per second back to absolute 0. So what is behind here in the block diagram? I include that program that we're running, plus when the extend has, here's the ActiveX setting the VR0 flag, and when the retract, setting the VR1 flag. In a further video, we'll get much more deep into the basic programming. So let's give it another example now. We're actually going to stop the program, and we're going to run only from LabVIEW. So let's show an example just showing jogging. This is a 2-axis jog routine where we have the setup on all the systems is the type, which is a stepper, units, speed, 25 millimeters per second, and acceleration. Plus we set up limit switches where they are hardware wired. So here, if we take a look, we can jog forward and jog reverse. We can go to the other axis and do similar. So let's see what the block diagram it provides here. This specific program, the jog program, provides the user not only with the functions, but also provides a producer-consumer template that you can use for your other programs. Here we can see when we do a jog, we then write the jog to this routine, which does our high-level jogging motion. So let's take a look at another example. This one includes a lot more information. Includes homing, relative moves, absolute moves, as well as demonstrating hardware limits, software limits, and position setup. Again, this is set up for 2 different axes. So let's see what happens when we run this. We can move relative moves, here like minus 10 millimeters, or we can run a positive on that axis. Some of the things we also have available to us are parameters. Any of these parameters we can write to. Here I'm demonstrating speed, and as well as read parameters. A good one to read is actually mPosition, or MPOS, which gives us an absolute position. Again, we can be running both axes, and we could be running them simultaneously. While I'm homing one axis, I can home both axes simultaneously, and we can choose what kind of homing is available. Let's take a little look at what's behind here on our block diagram. Right here, we demonstrate all of the initialization, controller setup, and each of the functions, such as the home function here, absolute, relative moves, absolute, and all of the functions that we described can then have examples being run on this screen. The next thing we're going to talk about is actually demonstrating how to run a servo with the LabVIEW toolkit. Okay, now let's talk about the servo examples. So this is an example of the servo that has a lot of the positioning as well. So we can see that we have a home function here. Different, this actually has a marker on the encoder that we can use. We're going to creep reverse to that marker. So let's take a look there. Additionally, we can do a move relatives and a move absolute. Under the axis setup, you see we have a few different items as well. Parameters. Our units are 8192 steps per rev. Again, this would be like 25 revs per second. But you'll see that we can also set up our position gains. The other things available on the servo, we can handle drive faults, which we'll demonstrate in a future video, and following error handling. What I'd like to demo now is another feature we have, which is tuning the servo. We're going to use the Motion Perfect again for this. As you see, Motion Perfect actually has an oscilloscope function that we're going to use. And the setup is available in our folders. So what we're going to do here is set up a trigger here and use a motion demo servo tune to demonstrate tuning. What we do here is actually set up a square wave into the servo, and then we can capture the actual motion. So let's take a look at that. So from here you can see the resultant movement of the servo. And if you look before, we now have capability of actually doing some tuning here. So let's take a little look at some of the parameters. We can do any of the different gains. For example, let's say we took the gain and instead of running at 1, we ran at 1.5. So we're going to make it a bit hotter. Now write the value. We can set the clear the oscilloscope again, and let's do another capture. And you can see the difference. Using these parameters, we can then tune the servo. So that concludes showing some of the demonstrations on using Motion Toolkit with LabVIEW.
That was awesome, Eric. Where can customers find the Trio Motion Toolkit in the LabVIEW environment?
That's a great question, J.D. Here's where you find the Trio Motion Toolkit. Go to any of your LabVIEW programs, and under the Tools pull-down, go to Find LabVIEW Add-ons. That'll bring you directly to the Trio Motion Toolkit under the NI Tools network. There, type in Trio, select Trio Motion Toolkit, and you will then be able to load it from the Trio Motion Toolkit screen and purchase it directly from NI. If there are any questions, please contact me or J.D. Teter at PowerMation, or Stephen Leeds at PowerMation, or Ed Novak at Trio Motion Technology.
Thanks everyone for watching the introduction to the Trio Motion Toolkit for LabVIEW. Look for follow-on videos where Eric takes us through the details of the Trio basic programming and the various functions available in the Trio Motion Toolkit. As always, if you like what you see, hit that like and subscribe button down below and look for more how-to content on the PowerMation YouTube channel. Thanks, have a great day.